Welcome for that earlier part. Energy spectral density. This energy spectral density have very high importance as the energy changes with respect to that area, with respect to time, with respect to flux density. So as there are composite kind of signal, composite kind of sound, complex kind of sound, energy spectral density seems to be falls off in that case, and this effect seems to be normally utilized in case of musical instrument. So compression, that regression, that compression and expansion, this effect normally utilized in case of artificial musical instrument. So you need to forcefully buck up some voltage, some sound level and boost up some sound level, depend on the requirement, depend on the interest. So noise reduction, normally this kind of story normally utilized in case of Dolby kind of system, Dolby system, DJ system, musical system. So noise reduction, the activity perform all this section, and this is normally in case of Dolby environment. So the harmonics and amplitude, these harmonics and amplitude have great importance, because this harmonics and amplitude, it define the tone information, the kind of tone that will be carried by particular sound system. And this tones system, or this that harmonic and sound level, or this amplitude level, this indirectly support for timbre, the quality of sound, quality of notes, those seems to be generated from that musical instrument. That quality of that musical instrument totally depend on the timbre that will be developed, and the combination of harmonics, the effect, and the amplitude, the strength of that particular sound developed. So voice have a different timbre, piano and guitar. So all those are varied based on amplitude, and one or two, those are somewhat varied based on that harmonics value. So this is somewhat about the intensity of the sound. Now this is all about for that pitch information of that particular sound. Now sound intensity or the amplitude. In the physical entity which changes with the time, that normally term as signal, and that signal changes with respect to time, that normally have the signal strength, and that is nothing but the intensity, that charge or the energy that will be available with that particular strength. Loudness, how louder your sound. This normally the sound intensity seems to be important in case of sound recording or sound generation. Sound recording, sound reordering, sound generation, sound that matching, in that case this sound intensity seems to be important. Then this sound intensity normally measured based on two criteria, based on acoustic level and based on electrical strength level. This sound can be measured with respect to acoustic level, means whatever your intensity developed by that particular sound, that pressure is somewhat measured, and this pressure perceived by the ear, perceived by the human ear, perceived by the audience, that nothing but the acoustic level measurement for that particular. Same way that loudspeaker, same way that microphone that you have. Microphone normally have dynamic again with a low working range. So that acoustic level, that will be incorporated for that. Electrical level, based on electrical level, your sound is converted in electrical pulses. Sound is provided to signal acquisition unit to some amplifier, some that conversion, and then that electrical pulses, those are generated this way. So electrical level, so sound can be measured with based on the electrical level, and though it is the acoustic level measurement, though it will be electrical pulse based measurement, electrical signal strength based measurement, but it is again in dBs. It is always in dBs, decibels, always in dBs or decibel. Typical formula for sound measurement in dBs is 20 log to the base 10 P upon P reference. P is the power received, P reference is the threshold that above that you would like to support. So P reference is the threshold power, and P is the actual measured power, P upon P reference. So 20 log to the base 10 P upon P reference. This normally gives you sound intensity, acoustic sound level intensity in dBs. Over here P reference value normally 0.000, 3 times 0 with a 2 dynes per centimeter square. dynes per centimeter square, because below that your ear is insensitive to hear the sound level below that. So that is important. So while you are measuring the sound level, so this is somewhat very important. Other than that, other than normal decibel, you can convert your sound in the form of decibel, decibel milliwatt, that with the help of dBm. It is the smallest unit. 10 log 10 P upon P0 upon P to P0. This P0 is the power strain that will be measured, that is nothing but the power strain that is measured at 1 milliwatt for that particular device, and P is the actual power that will be measured on that real time picture. So it is in decibel, dBm. This is smallest unit. Same way that some of the samples normally utilized in case of musical and speech activity, 0 dB sound level, normally the threshold hearing of that human being. 25 dB sound level normally for recording or storing for the sound. That 50 dB sound level, that will be acceptable for ambient room, for office. 70 dB sound level normally utilized in case of conversation between two people. 90 dB sound level normally utilized in home theater or in home communication, that some big structure home. 120 dB, it is for 120 decibel normally used in a rock singer, rock star. Those people, they are using this particular sound level, or they are having that image compression and that expansion, or sound compression and expansion based on this particular level. So this is all about for audio fundamental and sound related